Hello everybody, my name is Paul Lammertsma. I'm super excited to be here again today at DroidCon New York City to talk to you about what's new in Android and Google TV. Like what we always like to do at Google is like open with a couple of numbers, right? So why do we care about TV? So here's some great numbers. 1/3 of US households today are consuming more than 25 hours a week of content. So there's so much content available on the TV today, right? That's a no-brainer. That makes complete sense. But for Android TV, that means that we have seen continuous growth and momentum. So this past year at the Consumer Electronics Show, we proudly announced that we have over 110 monthly active devices, and that number continues to increase. 7 out of the 10 top smart TV OEMs are running Google TV, including Sony and TCL, Hisense, Skyworth, and those are more and more OEMs as every year passes. Pay TV operator partners, also 170. If you're not familiar with it, what a pay TV operator is, it's like some of these familiar names on the left, like T-Mobile and Orange are some big ones. Right, so what that also means is that now the majority of TVs being activated in the US are Google TV. So we are now the predominant player in this space. So you as a developer probably also care about building Android TV apps. So what we've done is we've now also launched some great new features that are applicable for TV, making Google TV more helpful year by year, bringing effortless access to their, my personal favorite form of entertainment. I spend a lot of time on the couch and I enjoy it a lot. So for instance, one of the things that we've actually brought to Google TV in the past couple of months is profiles. We started with kids profiles. We've also brought fully fledged profiles so that everybody has their own personalized space on the TV where you can get your own personalized recommendations and follow your own interests. You can save shows for your watch later, and the continue watching row also applies to you. Inside the kids profiles, you also have family safe stuff for the whole family, including parental controls and options to be able to, for instance, limit watch time. So inside these profiles, you as TV developers can curate personalized content using familiar things like the Watch Next API. So these are specific to each user's profile. They get their own curated content in their Play Next row. So if you're anything like me, probably you've also lost your TV remote somewhere between the couch cushions. I find this new feature inside the Google TV app that allows you to bring up a virtual remote on your phone a great way to be able to continue to engage on your TV in case such a travesty like losing your TV remote happens. It also allows, by the way, not just operating the TV like your remote control. You have a full touchscreen at your disposal, so you can use your phone's keyboard. To a developer, this is very important because it allows you to support conventional key input. So where you have, for instance, username or password input fields or search input fields, please remember that you can use regular key inputs there now. So don't think that you have to build out your own on-screen keyboard. In fact, I ask you, please don't do that because actually Gboard, it works fantastically on TV. So you get to edit text or input field on your TV app. Let Gboard pop up and do its thing, or let the user use their virtual remote on their phone. So the TV team is very committed to bringing helpful tools and products for developers, and what I want to spend the next, say, like 30 or so odd minutes doing is recapping what's new for developers in TV for Android 12 and Android 13. I'll take a couple of look at some other common topics as well, like media session is always a hot topic, validation tools for that as well. Basically the goal here is to really increase the performance and the reach of your applications. Right, so Android 12 has a focus area on 3 core topics. So the frame rate switching API is one great new area for developers to be able to use. In the US, maybe it's not so important, but if you're developing an application that is global support, you might want to be thinking about like how your application supports different frame rates on different devices. So I'm from Switzerland, and in most of Europe, we have basically 50 frames, like 50 hertz displays. Here in the United States, it's 60 hertz displays. So making sure that you have seamless transitions on panels that differ by region to region is a great way to make sure that you don't have jank and you have good performance on all devices. Now, second, 4K UIs on supported panels that are performant enough to actually push so many pixels onto a 4K display. We'll begin to support those as well. So you kind of have to be challenging your assumptions about all TVs are full HD. Think about how your UIs scale up from full HD to 4K. So here again, a frequent topic that we always raise is you should be designing your UIs so that they're responsive, right? So that they work well in different form factors, different resolutions as well. And finally, accessibility remains a big topic to us, as always. This new feature here for text scaling, it allows users to adjust the size of text on their screen. Now, this is not a new API. We're very familiar with this from Android mobile. Of course, you've always been able to change the text size on your screen. Now on TV, this is here as well, so now it's ever more important to be supporting text scaling on Android devices. This comes back again, by the way, to designing responsive layouts, because bear in mind, as users are changing the text scale of the text on the screen, it might be pushing around components inside your app. So design your apps responsively, test it, validate it, and you're going to have a good time. So I wanted to go a little bit in depth on the frame rate switching. So where you find this as a user inside the user interface of the app is here. It's an option called matching content frame rate. And what this means is if you have a piece of content, let's say you have, from my example that I gave earlier, say you have a piece of content that is 60 hertz, because we're in America, our content was created in 60 hertz, right? And you have a user that has a panel that is 50 hertz, there's this option that allows you to do a seamless transition. So if the user owns a panel that supports HDMI 2.1 specification for variable refresh rate, what you can instruct the panel to do is you can say, hey, my content was created at 60 hertz, can you please switch over? And if the panel does support that with the VRR specification, then it'll seamlessly switch, and your user will get the smoothest playback without any jank. Now, there are a couple of different ways of doing this. We have the set frame rate API on Surfaces. There's also some different APIs for native. So there's some couple of different ways that you can approach this. One little caveat here is, I guess there are two caveats here. First of all, this display inside the Android, inside Google TV's settings screen, it has also this option non-seamless, right? And that's in the case that the device that it is attached to doesn't support that variable refresh rate switching. And you can leave it to the user to choose to be able to switch over whether or not the device will do it seamlessly. And as a user, maybe you've actually experienced this. What will happen is, in that case, you'll probably see a black screen for a second, right? So not ideal. Seamless is usually preferred, and we'll see some ways that you as a developer can take control over that as well. And the other caveat that I would call out here is when you have content that is, say, 29.97 FPS, don't round that. Don't round it to 30. 30 is a different frame rate, so you want to be precise, right? So provide that floating point into the set frame rate call. Excellent. So let's see. Here we see the actual call into the set frame rate. We're providing a new refresh rate. Now, the flag that I provide here, set frame rate with frame rate compatibility fixed source, basically means that our source is not doesn't have another option. This is the frame rate from our actual piece of content. So we're asking the TV, like, hey, we cannot make any better option here. Either you're going to get a janky experience or you got to switch. And this second flag that we're providing into it is a change frame rate only if seamless. Effectively means that we only actually instruct the panel to do the seamless switch so that the user doesn't get that black screen in between. There are other flags that you can provide to force a frame rate switch if it's going to have like a bad experience. So basically what we're doing here is we're working on a surface. So what this means is that when the video is actually playing, that's when we set the frame rate. If you don't have direct access to the surface, for instance, because you're using ExoPlayer, and if you're using ExoPlayer, awesome, thank you. Then the player derives the optimal frame rate from the media and playback speed. So it's even less work because ExoPlayer understands which media is playing. It can take care of doing that for you. In that case, all you have to do is Actually nothing. I mean, under the hood, it's providing the surface set frame rate for you. And you can change the way that this behavior actually works by using ExoPlayer's set video change frame rate strategy, but probably the one that's working out of the box is good for you. So this is another great reason to be using ExoPlayer if you aren't already. Okay, cool. So we've been talking so far about when we want to change frame rate, when media is already playing, but what about when all of the content inside of our app is at the same fixed frame rate? So in Europe, again, a lot of the top content is recorded at 50 FPS. I'm thinking about broadcasters like the BBC in the UK. They record all their content at 50 hertz. So it doesn't really make a lot of sense for them to launch their app into 60 hertz only to switch to 50 hertz basically when any content is being played. So there's a way of approaching this. What we can do is we can switch over the preferred display mode as soon as the application gets focus. Now, to do so, we should first check if the user, we should first check if the switch will be seamless. Because we want to respect that user preference, right? So if the user has specified, hey, I only want a seamless switch, we should be respective of that. So first we check, will it be seamless? And then we also check whether what kind of alternative frame rates are available on the current display mode. Now, if the transition won't be seamless, we can check if the user has specified a preference to match the content frame rate. Now, this is respecting that preference that I was talking about a minute ago. Match the content frame rate always. That would be the option here on the where's my pointer? Here on the right. If the user has selected non-seamless, then we have this match content frame rate always, right? And only then do we actually specify the preferred display mode to one that matches our content frame rate. And we do that by actually setting the requested mode on our window manager layout parameters. All right, cool. So now with frame rate switching squared away and this, you're designing responsive layouts and doing all those things that are recommended. You're thinking about UX, like text scaling, you're thinking about 4K UI support. That means that you're well on your way to supporting all of the latest features from Android 12 for TV. Let's not also forget those other things that we launched with Google TV, curating age-appropriate content and dedicated Watch Next space, so separating those from separate other profiles. Those are also great ways to think about integrating with Watch Next API. So if you haven't already, now's a great time to be evaluating your TV app for Android 12 compatibility. So this is already available today. You can get it either on a TV emulator. We have emulators both with the Google TV experience and without Google TV experience, running the sort of the vanilla Android TV. And we also have the same offerings for our ADT3 developer device, which you can purchase from our hardware partner. Both of them running Google TV or not running Google TV. Excellent. So now Android 13 is bringing even more helpful experiences and tools. We've been looking at a couple of different areas. We've been focusing on optimizations for audio routes. Also, again, accessibility has come to the forefront, and performance is always an ongoing topic. So let me just dive straight in. So the anticipatory audio route, there's an improved API for the audio manager that we have now that allows you to anticipate which audio route will become available to you when you want to play something on the TV. I want you to be thinking about whether or not Dolby Digital Plus is available on the TV. So how do you get ahead of that? How do you know, hey, the user has this this hardware setup that makes it available? And the way of doing that is using the new audio manager, get direct playback support. So with Android 13, what you can do is you can now check if a specific combination of audio format and audio attributes can be offloaded or passed through for direct playback on the device. And what I mean with direct playback, it means that the audio is passed through in a supported audio route that means it won't be transcoded, right? So maybe you have like Dolby Digital, you're going to be passing it through, but somewhere along the line there's a device that's going to be transcoding it to PCM because you just have stereo speakers. So in the interest of reducing the bandwidth or giving the best dedicated audio experience to your users, you probably want to stick with your existing PCM audio track, right? That's just in stereo. So what we can do is, suppose we already have an audio format and audio attributes to use. In this case, I've selected Dolby Digital Plus with 5.1 sound. So if you want to know if direct playback is supported by this device, you can query get direct playback support. And if you're getting a response from that that is direct playback not supported, then you can probably fall back to a different format. Now, if we don't perform this check, the audio route might be, doing that transcoding I was talking about. It might be transcoded to PCM. That's a frequent thing that happens. And yeah, again, a waste of bandwidth, not the best audio experience. So this is one way of approaching it. This is very simple, right? If you don't get 5.1, then switch to something else. So this is in the interest of a small snippet. This is good, but we can take a more robust approach by evaluating the best audio profile. And we can do that because the best way of thinking about this is you want to query what the best audio route is before you create an audio track. Because creating audio tracks is needlessly expensive. It takes some time. You kind of have to play some audio, see if the device is actually supported or not. So doing it beforehand is a much better strategy. So let's build a snippet to see how we can accomplish that. First, we'll define a method that defines the best audio format for the active audio path. And we're going to take our audio attributes as a parameter, and what we have here is our return is an audio format that will be returning the best audio format. Now, we'll start by handling the default case, here just returning, in the worst case, as a fallback, our PCM. And we'll use get direct profiles for attributes there at the top to query the supported profiles. Now, in this manner, we can check if the active audio path supports Dolby Digital Plus, right? So we're checking if it supports Dolby Digital Plus, if it's present inside the audio profiles list. And if it doesn't, then we fall back to Dolby Digital. And if that isn't present either, then we finally fall back to PCM. So pretty much all the pieces are in place here. The only thing is that once we know that the direct playback of the audio profile is supported, we can do this similar trick. I haven't written out the code for this finding best sample rate or finding the best channel mask, but it's effectively the same thing. And now we have all the pieces that we need. We have the audio profile, we have the sample rate, we have the channel mask, and now we can actually build our audio format. And only now that we have all these pieces in place do we actually do that sort of expensive operation of creating an audio track. So this is already a great step in terms of performance, right? All right, moving on to accessibility. So we have this new system-wide user preference, which is called audio description. And what audio description is, I actually had kind of a bit of a hard time understanding what this is, because in my mind it kept on going back to captioning. So you remember how in the movie Forrest Gump, it opens into this scene with this feather floating around, and you see all these rooftops and everything, and eventually it lands on his shoulder or something like that. So what I did, that's an audio description. If you are blind or if you're visually impaired and you can't see exactly very well what's going on the screen, there's a dedicated audio track that describes what's happening visually on the screen. And this is an accessibility setting that on Android 13 users can enable. So your app can respect that user preference by querying this new API in the Accessibility Manager to comply, right? And it's super easy to do. So all we have to do is basically, from the Accessibility Manager, obtain the user preference for enabling this setting, and wherever your media player is being initialized, and you're setting up an audio track, or you're choosing which audio track, maybe you have different languages, probably one of those languages that you have available is audio descriptions, and you can just enable that audio track. So just checking for the user setting is super easy. I do want to call out, though, that it's probably also better to actually register a listener for this, because it's possible that the user enables this content while it's playing. Bearing in mind this is a visually impaired user, they may have some sort of accessibility service. There are third-party pieces of hardware that you can actually attach to your device that may enable or disable audio accessibility services. So maybe they've already begun watching something, they want to switch on the audio description track. So you can accomplish that with a very easy listener. All right, cool. In Android 13, there's also different layouts for keyboards supported. This is a feature that came to Android 13 for mobile. It's also available for TV. And as a game developer, you can also now use the keyboard layouts API to reference keys by their physical location. Now, I'm a bit of a gamer myself, so when I think about this, I'm immediately thinking about the WASD keys, right? What about French users, right? They don't have a QWERTY keyboard, they have an AZERTY keyboard, right? So the mapping of those characters might be different than what you're accustomed to. So if you're thinking about, the movement forward by pressing the W key, or the movement left pressing the A key, that might be different on a French keyboard. So how do we deal with that? When input devices are changed, what we can do is we can reference, we can remap directional keys from a non-QWERTY keyboard to what they would be on a QWERTY counterpart. And here we can see how we can identify which keys might correspond with a conventional, in this case, WASD layout by correlating a key code from a key location. And we use this with a very appropriately named method, get key code for key location. So yeah. So here on the right side, we see the key codes from a QWERTY keyboard, and we map those to the direction that we expect it to go. All right. Let's just get that cursor out of the screen. All right. Okay, cool. So with HDMI state changes, playback applications also now can be notified to save power. So one of the neat things about Android TV is it has all sorts of different form factors. You might have Android TV on your panel itself, you might have a dongle, you might have a set-top box, and there are different ways in which this interacts with your application. If you, for instance, have a Chromecast with Google TV like I do at home, when your application is idle, when you're playing some piece of media on your TV and the user actually switches off the panel will send a signal through HDMI to signal that basically it's switching off. So there's no sense in actually continuing playback. So if your app is playing media, make sure that you're integrating with media sessions so that you react to that signal. You'll get a signal, hey, please stop playing. This is great for energy, obviously, so that you're allowing the device to go into standby. And integrating with media sessions is an interesting topic. I'll talk about that in a little bit, and we'll do some validation show some validation tools as well. All right, in line with the core Android release schedule, Android 13 beta is currently available. You can also find this in the Virtual Devices Manager, and you can also install an image for this on the Android ADT3 developer device. There are loads more inside the release notes. You can be sure to check what else is new. Beta 4 is being released. Sorry, I was grasping which beta we're at now. Beta 4. All right, now moving on past what's new in TV, let's look at a couple of our common areas and features that are relevant to building great TV apps. So one key area that I want to emphasize here is using app bundles. Show of hands, who is using app bundles today? All right, who's not using app bundles? All right. So app bundles are a terrific way of reducing the size of your application, and this is especially relevant on TV. TV hardware is rather constrained, so they're very memory constrained devices. So this means that users are also more likely to uninstall applications to free up storage. So if your app is using a lot of space, it's probably the first one to go, right? And what we've seen in terms of app bundles is on average, apps save about 20% just by using app bundles. Now, of course, there are other benefits. You get faster app downloads. We've seen that this returns basically an 11% install uplift from the size savings alone. Also means that for you as a developer, it's faster releases. You don't have to be worried about multi-APK support. You have like the security benefits of using Google's security infrastructure to keep your keys safe and secure. And resetting your upload key is also possible in case you lose it or if it's compromised somehow. Sometimes we have new versions of our signing key for upgraded security. You get that out of the box as well. And one of the great things is you can also use dynamic feature modules. So yeah, really think about whether this is good for you. I can't really imagine a scenario where app bundles is not a good situation, but definitely take a look if you're not already. All right, voice controls. On the the Chromecast with Google TV, the remote has a Google Assistant button. Many TVs these days do. I think all Google TV devices have it. There are ways in which you as a developer can integrate with that through Media Session. And again, I'll talk about Media Session in just a minute. Actually, right now, perfect. So, in which ways do users control media? This is, I think the core question is like, it's not just TV, right? We control our media in lots of different ways. For one, Android platform itself. Here you see on your phone, you probably very familiar sight, right? Seeing the current playback of media on your home screen or in the quick settings shade. On your watch, if you're playing something on TV, I actually grabbed a screenshot of my own Galaxy Watch 4 here. And TV is just the same, right? So if you have ongoing playback in the background, that's Spotify playing in the background, that's all through Media Sessions. We also have different kinds of peripherals to control playback on our devices, right? We have, for instance, keyboards with media controls. On my TV panel at home, this is a photograph of my TV remote. Pressing the media buttons on the TV remote, it sends a signal through HDMI CEC to basically instruct playback through Media Sessions. Of course, media can also be controlled through accessories. Think about Bluetooth earbuds or wired headphones that have playback buttons, right? And finally, Assistant, through voice controls. So the easiest way of accomplishing this is using the Jetpack Media 3 library. It's extremely easy to connect your player with a media session. And in turn, by connecting your player to a media session, it allows Android TV to control media for you. Now, how do we accomplish that? It's actually super simple. The Media 3 library has made this way less work. So out of the box, all you really need to do is construct a media session from the activity context with an instance of your EXO player. Now, if you're familiar with Media 1 or Media 2, you might notice that we no longer have to use things like Media Session Connector. This is literally all you have to do. You can expand its functionality. Here's a session callback. You can add a listener to handle more controls. But if you're using EXO player and you have just content in there that you want to skip next, previous, all that stuff is supported out of the box. So with a reference to our media session, make sure to release it whenever you're releasing your player. It's very important that you release a media session because otherwise your media controls are no longer working. The user might be saying like play or pause and it's going to be controlling the wrong app. So just be a good citizen on the platform and release your media session. Cool, we have some media session validation tools. There's the Media Controller Test app, allows you to test the intricacies of the playback of media on Android. And it basically just lets you verify that everything's working correctly. This actually works through one-click tests, so you can automate this as well. And it works not just for TV, there's also a mobile component for this. Next to that, we also have the Media Session Validator. This one's a bit more tailored towards integrating with the prerequisites for supporting Cast Connect. All right, this is manual validation. This is rather detailed. I don't think I have enough time to actually go into detail on this. So I'm going to skip over it, but basically what we're interested in figuring out is from dumping the content of our media sessions, take a look at this. This is our actions. And in this case, this is YouTube. YouTube is reporting that the actions bit integer sum is 362, and we can break that apart using the constants from our playback state. And you'll see that this is a bitwise sum of a number of different actions, including seek to support, fast forward, et cetera, et cetera. So you can do this as well. One other way of doing manual validation is through media commands, using the dispatch media commands through ADB. There's also an interactive shell that will actually allow you to monitor in real time what's happening with your media session, and it allows you to perform a couple of commands here as well through play, pause, etc. All right, just as a little bit of a recap here. A checklist of getting a media session nailed. Make sure you only have one. That's a bit of a no-brainer, but make sure you only have one. Make sure you're only setting it to active or inactive when playback is actually being supported inside your application. And update any changes to the playback state as well. update any changes to your media metadata as well. Those core commands, do the validation on that using those techniques that I suggested, and finally also make sure that you release it, being that good citizen. A couple of common pitfalls that I've seen: don't expect that you can just use key commands instead of media sessions. A lot of those interactions that I was showing a little bit earlier, like voice commands and peripheral support, that's not going to work if you don't actually go the full length to make media session work. And again, be cognizant of using the active, setting it to active or not. And also, one thing to point out here is what happens with lifecycle changes. All right, I think we're pretty much at the end here. I have one last thing here about ambient mode. You may be familiar with this screen, right? When your TV idles, you go to this ambient mode after 10 minutes of doing nothing. What this means for your app is, I can't believe I have to say this, there are apparently developers that have not gotten this squared away. Just prevent it from going into ambient mode when content is playing on your TV, right? If you're going to be watching a movie and after 10 minutes the TV switches off, not the best user experience, right? Flip side of this, of course, is, here's the integration of it, right? So you're going to set a flag, or you can even do it on the layout. Super easy. Similarly, make sure that your device will switch off if you're no longer playing video content. So if you registered that flag programmatically, clear the flag out once you're done. A little call out here for Cast Connect. Cast Connect is a tremendous opportunity to drive better engagement on your TV apps. So don't just think about like throwing a cast session to your TV and having the user watch one piece of content. Cast Connect allows you to leverage the fact that the user might have a native TV app installed, right? If they have a native TV app installed, they can pick up their TV remote, continue to browse. So this is great for engagement. So explore the developer documentation on that. We have a great code lab, by the way. We also have great quality guidelines here, so take a look at the quality guidelines. This actually outlines different areas in which an app might be rejected for TV. We have changed some things there recently. Ambient mode is now, thanks to some really bad developers, is now inside the policy. So yeah, you might want to check the quality guidelines. And finally, we have a itemized list of recommendations to get aligned with those quality guidelines. Here are the checklist, also on the developer site. We have more content on our YouTube channel. I'm over there, but I have some great teammates that have covered some other great topics, including accessibility, billing, Watch Next API, and account linking is also a great way to reduce friction for your users as they install the apps for the first time. And with that, I think we're a little bit over time, actually, so thank you very much for listening.